What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about application attacks such as privilege escalation, cross-site scripting, code injections, pointer object dereference, directory traversal, buffer overflows, race conditions, error handling, improper input handling, and replay attacks. Let's talk about privilege escalation. So privilege escalation, this is the act of exploiting a bug, a design flaw, or a configuration oversight in an operating system or software application to gain elevated access to resources that are normally protected from an application or user. The result is that an application with more privileges than intended by the application developer or system administrator can perform unauthorized actions. This type of attack can involve external threat actors or be an insider. Next, let's talk about cross-site scripting. So cross-site scripting attacks use known vulnerabilities in web-based applications, their servers, or the plugin systems on which they rely. Exploiting one of these, attackers fold malicious content into the content being delivered from the compromised site. When the resulting combined content arrives at the client-side web browser, it has all been delivered from the trusted source and thus operates under the permissions granted to that system. By finding ways of injecting malicious scripts into web pages, an attacker can gain elevated access privileges to sensitive page content, to session cookies, and to a variety of other information maintained by the browser on behalf of the user. Next, we have code injections, and this is the exploitation of a computer bug that is caused by processing invalid data. The injection is used by an attacker to introduce or inject code into a vulnerable computer program and change the course of execution. The result of successful code injection can be disastrous, for example, by allowing computer viruses or computer worms to propagate. Code injection vulnerabilities occur when an application sends untrusted data to an interpreter. Injection flaws are most often found in SQL, DLL, LDAP, and XML parsers, etc. Injection flaws tend to be easier to discover when examining source code than via testing. Scanners and fuzzers can help find injection flaws. Injection can result in data loss or corruption, lack of accountability, or denial of access. Also, injection can sometimes lead to a complete host takeover. The types of code injections that you need to be concerned with in regards to the CompTIA Security Plus 601 examination are SQL, DLL, LDAP, and XML. So let's talk about the first one, SQL or SQL or structured query language. And this is used to attack data-driven applications in which malicious SQL statements are inserted into an entry field for execution, such as dumping the database contents to an attacker. SQL injection is mostly known as an attack vector for websites, but can be used to attack any type of SQL database. SQL injection attacks allow attackers to spoof identity, tamper with existing data, cause repudiation issues, such as voiding transactions or changing balances, allow the complete disclosure of all data on the system, destroy the data or make it otherwise unavailable, and it allows attackers to become administrators of the database server. Next, we have DLL or dynamic link library attacks, and this is used for running code within the address space of another process by forcing it to load a dynamic link library. DLL injection is often used by external programs to influence the behavior of another program in a way its authors did not anticipate or intend. So for example, the injected code could hook system function calls or read the contents of password text box, which cannot be done the usual way. A program used to inject arbitrary code into arbitrary processes. This is known as a DLL injector. Next, we have LDAP or lightweight directory access protocol attacks, and these are used to exploit web applications which could reveal sensitive user information or modify information represented in the LDAP data stores. LDAP injection exploits a security vulnerability in an application by manipulating input parameters passed to internal search, add, or modify functions. When an application fails to properly sanitize user input, it is possible for an attacker to modify an LDAP statement. And then we have XML or extensible markup language attacks, and these are used to manipulate or compromise the logic of an XML application or service. The injection of unintended XML content and or structures into an XML message can alter the intended logic of the applications. Further, XML injection can cause the insertion of malicious content into the resulting message or document. Next, we have pointer object dereference. So pointer dereferencing, this is common in programming. So when you want to access data such as an integer in memory, dereferencing the pointer would retrieve different data from a different section of memory or perhaps a different integer. Programs that contain a null pointer dereference generate memory fault errors, also known as memory leaks. A null pointer dereference occurs when the program dereferences a pointer that it expects to be valid but is null, which can cause the application to exit or the system to crash. From a programmatic standpoint, the main way to prevent this situation is to use meticulous coding. Programmers can use special memory error analysis tools to enable error detection for a null pointer dereference. Once the problem is identified, the programmer can correct the code that may be causing the errors. Next, we have directory traversal. So a directory traversal, also known as a path traversal or a .. attack. This exploits insufficient security validation or sanitization of user-supplied file names, such that characters representing, quote, traverse to parent directory are passed through to the operating system's file system API. An affected application can be exploited to gain unauthorized access to the file system. It is often used on web servers that have PHP files and are Linux or Unix based, but it can also be perpetrated on Microsoft operating systems, and those are known as .. attacks. It is designed to get access to files such as the ones that contain passwords, and this access can be prevented by updating the operating system or checking the code of files for vulnerabilities, and this is also known as fuzzing. Next, we have buffer overflows. So a buffer overflow, this is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundary and overwrites adjacent memory locations. Buffers are areas of memory set aside to hold data, often while moving it from one section of a program to another or between programs. Buffer overflows can often be triggered by malformed inputs. If one assumes all inputs will be smaller than a certain size and the buffer is created to be that size, then an anomaly transaction that produces more data could cause it to write past the end of the buffer. If this overwrites adjacent data or executable code, this may result in erratic program behavior, including memory access errors, incorrect results, and crashes. Next, we have race conditions, and these are also known as time of check to time of use attacks, and they take advantage of the need that computing systems must execute some tasks in a specific sequence. In any such sequence, there is a small period of time when the system has carried out the first task but not started on the second. If this period is long enough or the attacker is lucky and knowledgeable, a race condition vulnerability exists where an attacker can trick the system into carrying out an unauthorized action in addition to its normal processes. Next is error handling. So improper error handling flaws occur when an error message that's displayed to an end user provides clues about how an application or website operates. Although messages like this can help developers fix problems on their sites, they also show attackers information that they can use to help them break into what should be considered a secured area. So for example, an error message that includes information on the structure of a SQL database table may give attackers everything they need to know in order to carry out a successful SQL injection attack. Next, we have improper input handling. So improper input handling, this is a term used to describe functions such as validation, sanitization, filtering, or encoding and or decoding of input data. Improper input handling is a leading cause of critical vulnerabilities that exist in today's systems and applications. The root cause of improper input handling is the application trusting rather than validating data inputs. One of the critical aspects of input handling is validating that the information satisfies specific criteria. All inputs should be considered untrusted as they come from various mechanisms and be transferred in multiple formats. For proper validation, it is essential to identify the form and type of data acceptable and expected by the application. This is required to define restrictions and avoid improper input handling attacks accurately. And then we have a replay attack. So a replay attack, this is a form of a network attack in which valid data transmissions are malicious maliciously or fraudulently repeated or delayed. This is carried out either by the originator or by an adversary who intercepts the data and retransmits it, possibly as part of a spoofing attack by IP packet substitution. This is one of the lower tier versions of a man-in-the-middle attack. Replay attacks are usually passive in nature. Another way of describing such an attack is an attack on the security protocol using a replay of messages from a different context into the intended or original and expected context, thereby fooling the honest participants into thinking they have successfully completed the protocol run. All right, so that was my quick little class on application attacks. So let's do some of this wonderful check on learning, shall we? So the first question is, which type of injection attack occurs when code is run within the address space of another process, forcing it to load another library? Would this be a DLL injection, an LDAP injection, a SQL injection, or an XML injection? So which one of these occurs when code is run within the address space of another process, forcing it to load another library? And the correct answer is, this would be a DLL injection or a dynamic link library injection. Next question. Race conditions are also known as what type of attacks? Would these be heap overflows, TOC, TTOU attacks, stack overflows, or buffer overflows? So race conditions, these are also known as what? And the correct answer is, this will be a TOC, TTOU, or a time of check to time of use attack. Next question. Which type of attack occurs when an attacker might use a packet sniffer to intercept data and retransmit it later? Would this be an overflow attack, error handling attack, cross-site scripting attack, or a replay attack? So which one of these may use a packet sniffer to intercept data and retransmit it later? And the correct answer is, this would be a replay attack. All right, so in summary, we have talked about application attacks such as privilege escalation, cross-site scripting, code injections, pointer object dereference, directory traversals, buffer overflows, race conditions, error handling, improper input handling, and replay attacks. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.